All right, in this problem, we're given a mass of 1,500 kilograms for this car. It's accelerated from rest by a force that stays constant at 1,000 newtons for a known amount of time, so 10 seconds. And I want to get the work done by this force. So on this problem, I have the magnitude for the force and the direction. And I know the time it operates for, but what I want is the distance it operates for. So work is going to be, like, this is the constant force case, so you don't have to do an integral. You just take F times delta X. And in fact, delta X is in the same direction as F, so I'm not even worried about that, the cosine theta part of the work formula. So there's my delta X. So they point in the same direction. Theta is 0, so my work formula is as simple as possible. The problem is I don't know delta X. So my initial velocity, by the way, is 0. So I've got to do some kinematics to figure things out. How far is this thing moved? So I've got to use this force and the mass to find out how fast it's accelerating. So A is equal to F over M. So F over M. So I get 0.667. I'll just keep 3 sig figs meters per second squared. I can assume we started x equals 0. I know that the initial velocity was 0 because of this statement, that it started from rest. So I should be able to use kinematics to find out how far it's gone, and then I'll know the distance the force has been applied through, which is what matters. Initial position was 0, initial velocity was 0, and I can finally get my displacement for this motion. If I'm not going to put units on A, I'm not putting them on T either. All right, so I get 33.4 meters for the distance that this force has been applied through. And so finally I can go back and say the work done is 1,000 newtons multiplied by 33.4 meters, which would give me 33,400 joules. Part B, I want to use the work energy theorem to compute the final speed. So there's nothing else going on. I didn't even mention anything about friction, so the assumption is that it's negligible. So work is delta K, change in kinetic energy, that's final minus initial. It started from rest, so again, the initial kinetic energy is 0. And maybe just to have a little variety, I'm going to go ahead and put in the numbers first and then solve for V final. You can also do it symbolically if you like. So multiply by 2, divide by 1,500, square root the result. And I get that V final is 6.67 meters per second, just keeping 3 sig figs as usual.